High above our planet, a silent battle rages between the relentless energy streaming from the sun and the invisible protective shield surrounding Earth. This cosmic interaction, while invisible to our eyes, has profound consequences for the technologies we rely on every day, jeopardizing satellites, disrupting power grids, and threatening communication networks. Understanding and predicting these dramatic space weather events has become one of NASA's most urgent scientific frontiers. On July 23, 2025, NASA took a major step forward in this quest with the launch of the Tandem Reconnection and CUSP Electrodynamics Reconnaissance satellites, known as tracers. This mission, consisting of two identical satellites, is designed to unlock the secrets of how the sun's solar wind, a stream of charged particles, interacts with Earth's magnetic field. By investigating these powerful interactions, Tracers aims to provide the critical data needed to protect our modern world from the very real dangers of space weather. Earth's magnetic field acts as a protective cocoon, shielding us from most of the solar wind's fury. But at certain points, this shield is tested. The solar wind can breach the magnetic barrier through a process known as magnetic reconnection, where energy from the sun is explosively transferred into Earth's space environment. This can trigger geomagnetic storms, causing dazzling auroras, but also posing risks to satellites in orbit and electrical systems on the ground. Tracers is specifically engineered to study these magnetic reconnection events in unprecedented detail. The two satellites fly in tight formation through the polar cusps, regions near Earth's magnetic poles where the protective field is naturally weaker. Here, the solar wind can penetrate more easily, making these zones critical laboratories for observing the very moment when energy from the sun enters near-Earth space. Each tracer's satellite is equipped with advanced instruments to measure electric and magnetic fields, as well as the properties of charged particles. By collecting synchronized data from both satellites as they pass through the cusp regions, scientists can capture a three-dimensional picture of how magnetic reconnection unfolds. This dual perspective is crucial for understanding the precise mechanisms that trigger space weather disturbances. But Tracers is not alone in NASA's coordinated effort to decode the sun's influence on our planet. In December 2024, the Parker Solar Probe achieved a record-breaking close approach to the sun, coming within just 3.8 million miles of its fiery surface. The probe's daring journey provided the closest ever images of the sun's corona, capturing dramatic interactions between solar eruptions and the solar wind. These insights are deepening our knowledge of where and how solar storms begin, offering vital clues for predicting when dangerous space weather might strike Earth. Adding another layer to this scientific campaign, the polarimeter to unify the corona and heliosphere, PUNCH, launched in March 2025. PUNCH offers global, three-dimensional views of the sun's corona and the solar wind as it streams outward through the solar system. By mapping the transformation of the sun's atmosphere into the solar wind, PUNCH enhances our understanding of the origins and evolution of space weather. Together, these cutting-edge missions form a powerful network, each contributing a unique perspective on the Sun-Earth connection. The data gathered by Tracers, Parker Solar Probe, and PUNCH is already yielding new insights into the timing, intensity, and triggers of space weather events. This research is more than just scientific curiosity. It's a shield for our technological civilization. By improving space weather forecasting, NASA is helping to safeguard everything from orbiting satellites to the power grids that light up our cities. The launch of Tracers marks an exciting new era in heliophysics research. As the mission unfolds, scientists and engineers will be watching closely, eager to translate its discoveries into practical tools for predicting and mitigating the hazards of space weather. In the coming years, thanks to missions like Tracers, our understanding of the sun's dynamic influence will only grow, ensuring we are better prepared for whatever our star sends our way.